Hello everyone, welcome to today's class of set. Uh, so let's get right into it. So what is set? Hmm, in our daily life, we sometimes use the word set to indicate a group of objects. So in math, it's also used for similar reasons, but here uh, the elements of a set, which are what makes up the set, are a bit defined. So, how do we define a set? Say, uh, in a bookshelf, there are um, three English books, uh, four math books, and five um, biology books. So, we could say that the bookshelf contains of books uh, which can be defined by a set, say S, where we can represent this by E, 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 M, 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 and B, V, V, V. So this is a set. The elements of the sets are the books, and this is a way of representing this set. So now we can say that, um, say E is an element of S, right? So here you can see that E is an element of S. This is the notions of the sign or letter, whatever you say, is what we use to identify to define that E is an element of set S. Uh, Now, this is a way of representing a set. This type of method for representing set is known as tabular method. It has another name, such as row star method. So, uh, say there is a set called A. There is a set called A. It consists of the number 2, 3, 5, 7, 11, 13, and 17. And there is another set B, consists of B, O, Y. So here we're representing set A and set B. We are representing set A and set B, where the set A consists of the elements 2, 3, 5, 7, 11, 8, 13, 17, and B consists of the element B, O, Y. So this is called the tabular method. This is called the tabular method. And also, it has another name, the roster method. There is another way of representing set that's called a set builder method. It's a bit different from this one. In the set builder method, instead of writing down all the elements, we'd use a rule. We would use a rule uh, to define what type of elements the set consists. For example, if A is set written like this, So what have we written over here? We've written set A and we've written X and then we used a colon. So what does this colon mean? This colon uh, translate to as if. So X as if X even natural numbers. So X would mean all the even natural numbers. So what are the even natural numbers? So the even natural numbers would mean that 2, 4, 6, 8, 10, 12, and so on. So A would be a set that would consist of the element X, where X is even natural numbers. So this is another way of representing a set, and this way is known as the set builder method. It's known as the set builder method. So what do we have up to now? That there are two ways of representing set. There are two ways of representing a set. One is the tabular method, and another is the set builder method. Remember that these elements are definite, defined, so that we can clearly understand what this set consists of. It's not typically how we do it in our regular life, like how we say it. A set of books, which is a bit undefined, right? Because we don't know what books they are. If we say a set of math books, a set of high school literature books, and we get a clear idea of what set of books these are. So elements of the set have to be well defined, so we can get an idea of what this set is. Here let's see an example. In our first example, we'll try to represent all the division of Bangladesh in a set. It is both the tabular method and the set builder method. So for the tabular method, we'll write S is equal to at first, like there are 8 divisions. There are 8 divisions of Bangladesh. So we'll write Dhaka, Chittagong, Dhaka, Chittagong, Khulna. We'll write Rajshahi, Barishal. If you're watching the video, you'll be fairly familiar with these divisions. And the last one, oh wait. There are 2 more after this one. Sorry, got it wrong. Right. There's the 21s. And last one. Maiman Singh. So these are all the 8 divisions of Bangladesh. All the 8 divisions. 1, 2, 3, 4, 5, 6, 7. So this is a tabular way of representing all the 8 divisions of Bangladesh. And now, if we are to represent this in the set builder method, then this would look like this. So this would look like this. So here, representing set X with an element called X. Now what is X? We are defining X by a rule that is X is a division of Bangladesh, and we know that there are 8 divisions. So the set X, the set S consists of element X, which will be any division of Bangladesh. So this is the set builder method of representing this set. Okay, let's start. Let's try to go through some definitions of set. Firstly, the finite set. The finite set would mean a set with finite number of elements. For example, B, if written as a set, then it will consist of finite number of elements. Say, for example, um, A, C, D. So B, the set, the finite set, which consists of C, A, C, D, that is in 3 elements, does B, the finite set. Now, if B didn't have any finite number of elements, that is, if it has elements uh, that were infinite number, then we could have defined B as an infinite set. Say, for example, if B was uh, like this, right? So this goes on for infinity, then this could be defined as an infinite set. Now, uh, two sets can also be equal. For example, we could write A is equal to P, where A might consist of the element, say, 1, 2, 3, and P would consist of element 2, 3, 1, 2. So this is uh, the equivalence or uh, equality of two sets. Notice that the elements of the set's order does not matter here. What matters is that they have the same elements. There's another thing called the subset. The subset is that if, say, A is a set consists of 2, 4, 6, and 8, and B is another set which consists of 2, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then A can be considered a subset of B. How do we get to this conclusion? If you notice, you'll see that B consists all the elements of A. Here A consists of 2, 4, 6, 8, and B also consists of 2, 4, 6, 8. Thus, we can write A as a subset of B. And to define a subset, we use this identifier symbol. We define the subset. Now, there's nothing called a real set. If, say, if say B was a set, say suppose, and so here B has all the elements of A. B has all the elements of A, plus it has another element which the A does not consist. Then we could say that A is a real set, a real subset of B, and we can write that as A is a real subset, is a real subset of B. So this can be more than one, like this here. This the number of elements that B has to have, which does not belong to A, can be at more than one. It at least has to be there. At least has to be one element that B has that it does not have. Then we can say that A is a real subset of B. Also, there is this set called empty set. Empty set is when there are no elements in a set. For example, if say Z is a set, okay, Z is a set where X its elements belongs to or is uh, it's uh, an element of natural numbers. So Z consists of element X, which is in terms elements of natural numbers. And what is the rule that would define Z? Set Z. The rule, if we set that X will be smaller than N and will be greater than 10. So Z will consist of element named X, which in terms is element of the natural numbers. And the rule for this set is that X will be less than 9 and X will be less than 10. But if you notice, you'll see that there are no natural numbers that are less than there are no natural numbers that are less than 9 and greater than 10. So these type of sets are called empty set, and they are represented either like this, or like this. Okay. So these are empty set. There can be a lot of other examples, but we'll skip for now. There's this set called the universal set. Universal set is when say we're talking about multiple sets and you combine all of this set, all of the elements fall under one single set, then that one single set will be known as the universal set. Say, for example, A is a set consists of 1, 2. B is another set. It consists of 3, 4. C is a set. It consists of 2, 3. We can write a universal set like U is a set of 1, 2, 3, 4. So let's see that this set consists of all the set. So the sets that make up the universal sets, A, B, C, are all a subset of this set. So when we're talking about multiple sets and they're all a subset of a particular set, and that particular set can be termed as a universal set. Now there's this another set which is called, it's not a set actually, it's called a union of set. So if say we were to add set A and set B and get a set where all the elements of A, B are present, and we can define this new set as A union B. Also, there's another term, it's called intersection set. If say we are to write a set D, which will have the common values of B and C, which is say here 3, right? They have the common values of B and C is 3. Then we can write this as B intersection C. We write this as B intersection C. There's another thing is the disjoint of sets. Say if A two set if two sets have no common elements, then we can write that it's an empty set, right? It's an empty set, and that's called disjoint set. That is that both sets are disjoint to each other. So, for example, here you can see that A intersects B is an empty set, right? It's an empty set because it does not have an element in common. So this is called A disjoint and B disjoint to each other. There's another thing called complementary set. To define a complementary set, I think it's best we try to understand what's Venn diagram. The Venn diagram is basically representing sets in a geometrical way. Say, for example, say if we do it from these examples, this would be nice. Let's try to draw set A. Let's draw A in a circle, right? So it has 1 and it has 2. Let's draw B. Okay, let's draw B. B has 3 and 4. Now let's draw C. C consists of 2 and 3. So we have here, we have A, we have B, and we have C. So we can also now draw another thing. We can draw a rectangle. To define a universal set which consists of all the elements of A, B, and C, that we can say that A, B, and C is a subset of them. So this is a universal set. So this way you're representing set is called the Venn diagram. The Venn diagram. Venn diagram was this came from John Venn, really from 1834 to 1883. Now, what we're trying to say is complementary set. Complementary set is basically say if this is a universal set and this is a subset of this universal set A, then all the other elements of this universal set except this set A are termed as complementary set of this set A. So we can say is that the elements that the universal set A has which are not of A are called the complementary set of A. This can be written as like this. It's not written as like this. Mm, okay, I'm a bit tough right now, so I'm speaking a bit slowly and words a bit mixed up. Hope it you can still understand what I'm saying. Okay, these are all the definitions and classifications and set. Let's see if we can try out some examples. For our first example, so we have, so we don't need this or anything. Mm, okay, let's try it out and union or set here. Example number 2, because we did one example before. So say A is a set. Okay, a set consists of the values or elements 1, 2, 3, 4, and B is a set consists of the values 2, 4, 6, 8. We can write A union B as 1, 2, 3, 4, 6, and 8. Notice that uh, that 2 and 4 are both present in both the sets, but we did not write them uh, twice here. Instead, we write them only once, since they're common in both the sets. So we write union of sets. Similarly, we can try out the intersection of sets. You can also try out empty set like this. Okay, let's look at some ways of expressing typical type of set. And we're going to be using the set builder method over here. Uh, let's say we want to define a set of natural numbers that are smaller than 10. So how do we do it? We do it like this. We write A, which is the set. It consists of element X, which is a set of natural numbers, but these numbers are smaller than 10. So we're going to define a set of natural numbers that are multiples. They're multiples of 16. You can do it like this. We define this as B. Then the element of B is X, and X is a set of natural numbers, or is the element of natural numbers. But X is also divisible by 16, which means that X is a number which is a multiplier of, is a multiple of 16. So if you want to define a set which consists of only natural numbers, but there are factors of a particular number, say 7, then we can define this set as, again, X will be a set of natural numbers, but then X is a factor of 7, so we can write it like this, right? So X has to be a number that can divide 7 to get another natural number. The X has to be a factor of 7. And 7 only has two factors, 1 and 7. So if we put these in here, then we'll see the results are like we get 7 or we get 1. So this becomes natural numbers. So that's how we can define this sort of set. Say if X is a natural number, but it is less than 30, but is also a prime number. Then we can write this as, again, the natural number. So but x is less than 30, and that is out. And x is a prime number. Prime number. So this is how we can represent a prime number, which is a natural number, with a condition that it's less than 30. And you can use any other conditions. It can be greater than this, greater than equal to any other way you can define it. It's up to you. Say if you want to define x, so if you want to define a set, say E, where we want to define a set of numbers where the square of the natural numbers will be greater than 10, the cube of those natural numbers will be less than 100. So you want to represent a set of natural numbers. So a set of natural numbers where the square of these numbers will be greater than 100 but less than 10. So we can write it the square of this number will be greater than 10 and less than, and the cube of these numbers will be less than 100. These are some ways we can present some typical type of sets. Now, say if asked that there are two sets named A and B, and subsequently uh, they are the sets of all the factors of 108 and 87. So how do we do such math, right? So A and B are A and B are two sets where A is a set consisting of all the factors of 108. Factors of 108, and B consists of all the factor of 87. And how we have to first write down all the factors. I'm going to do it shortly after you write down all the factors. And you write them down here serially from smallest to the largest. You'll see that it'll be somewhat like this. Yeah, this will be said. Also, and then write this similar ways. Similar way we can write this, and this would be very simple as it is. So these are the two sets. Now say if we're asked that to write a set of natural numbers which, if we're used to divide 346 and 556 each and every time, 31 is left as reminder. If we're asked to find out this set like this, then how do we do it? So first, let's start to simplify things. So we are asked to write down a set say A, which consists of all natural numbers, right? Which consists of natural numbers, but it consists of only those numbers that, when used to divide 346, 346, and 556, a remainder of 31 is left. So what we need to do is we'll first need to subtract 31 from 246, and we get 15. Also subtract 31 from 556, so we get 525. Now all we have to do is we have to find all the factors of these two numbers. We have to find all the factors of these two numbers and see the common numbers between those factors. And if we try to find the factors, we'll see that, say, if we term that as A, we'll see that it consists of 35, 45, 63, 105, and 315. And if we do it for this, the factors would be 35, 75, 105, 175, and 525. And if we want to write down what's the common between these two, let's see that there's 35, there's 105. And these are the only two common numbers. Thus, we can say the union be the set that if it consists of a set of natural numbers, which when used as a divisor for numbers 246 and 136, we get a remainder of 31 each and every time. Now for our last example, we're told that in an exam, 80% of the students pass in math and 75% of the students pass in Bangla or Bengali. 60% of the students pass in both the subjects. Then, what's the percentage of students that fail in both the subjects? To solve this math, we would use the Venn diagram. Okay. Let's first use some. Let's try to identify the sets. Say, let's say that since we're doing it in percentage, let's say the total of 100 students, right? So there are a total of 100 students. Now, within this 100 students, we have students who pass in math. These are the students who passed in math. And these are the students who passed in Bangla, right? And these are the students who passed in both Bangla and math. So we had for math 80%. For math there was 80%. 80% for Bangla. We had 70%. But for both we had 60%. 60%. So for only math, we would have 80 minus 60 because we think is 80% there are students who also passed in math. So if we subtract that, 60% will get students who only passed in math. Okay. Same here in Bangla, within the 70% there are students who passed in math, but we don't want that. We want the students who passed in Bangla only. To figure that out, we have to subtract this from the union, and we get that 10% of students, only 10% of students passed in both Bangla and math. Now, if we add these numbers, add this 20%, 60%, and 10%, we'll find the number of students who passed in at least one subject, right? So if we add 20, if we add 20 plus 60 plus 10, it would add up to 90, right? So 90% of the students passed at least in math subject. So they either passed in math, they either passed in Bangla, or they either passed in both Bangla and math. So if we subtract this number from total number of students, we get a number of percentage which would indicate number of students, percentage of students that didn't pass in any of the subjects. Thus, the question that we were asked is how many of the students failed in both the subjects. So 10% of the students failed in both subjects. So that was our last example. Hello everyone, welcome back to our class of set. In the last class we talked about some definition of sets, its classification, and went through some examples. In this class we're going to solve some problems. Here we have a set of problems which we have to solve to understand the topic of set even better. So for the first problem, we are asked to identify if the following statements are true or false. This was previously done, so I'll have to go through them to make sure that you understand. So here, A is a set. Okay, here A is a given set, and then we are asked which should be which is appropriate to use between this element and set A. If say this 5 belongs to set A, then we'll use this, and if it doesn't belong to A, we'll use this, which we have learned previously. So as you can see that A consists of the elements 1, 2, 3, 4, 5, and 6. Thus, we can use this belongs to or epsilon sort of or subset sign to indicate that 5 belongs to it. Similarly, since 8 does not belong to set A, that is 8 is not element of set A, we'll use this sign to identify this. Again, since 4 is an element of A, we'll use this sign. Since 0 is not an element of A, we'll use this sign, and since 10 is not an element of A, we'll use this sign. Now, in the next question, we are asked that in the next question, we are asked to identify if a given set is a subset of another set. So here, say if this given set, which consists of elements 2 and 3, is a subset of another set which consists of elements 1, 2, 3, 4, we'll use this sign, and if it is not, then we'll use this sign. As 2 and 3 is also present in the following set, then we'll use this sign to indicate that this set is a subset of this set. Again, since A, B, and C altogether does not is not present in the following set, then this is not a subset of the following set, as 1 is absent. As you can see, 1 is not present here. In the third problem, we see that we are told x is an element. X is the element of this set where x is defined as the x is defined as the last 9 students of your school, and the following set also consists of an element x where x is defined as the students of your school. Now, definitely, the students of class 9 are also students of your school, so we can use the sign that indicates subset. In the next problem, okay, in this problem, the first set is a set that is consistent of the element x, where x is defined as the set of natural even numbers, and the following set consists of the element x, where x is defined as whole numbers. Now, what are the natural even numbers? You know, the natural even numbers are, the natural even numbers are 2, 4, 6, 8, and so on, whereas the whole numbers are 0, 1, 2, 3, 4, and so on. Here you can see that the natural even numbers are also included in the whole numbers, because we can say that the first set is a subset of the second set. Now, in the following problem, we are asked to represent the following sets in the tabular form. Here what we can do is that here the following sets are given in the set bender method. We have to express in the tabular. Okay, now here in the first problem, we have to create tabular form of this set where the elements will be of natural numbers, but the squares has to be greater than 15, but the cube has to be less than 100. So if we write the natural numbers 1, 2, 3, 4, 5, 6, or say, now 1 square, if you notice, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So 1, 2, 3 can't be an element of this set. They can't be an element of this set. Now, if we try to estimate the cubes, we'll find that 4 cube is 64, but 5 cube is 125. So it seems that 5 can also be an element of this set, as well as the numbers following 5. The only member of this set will be 4. 4 is the only member of this element. For the next problem, where again x is a natural number, but these natural numbers and their squares are less than 13. That is, if we write down this, say it's natural numbers, right? 1, 2, 3, say 4, right? Now afterwards, if we take their squares, we'll get 1, 4, 9, 16. The condition is that x squares to be less than 13. So 4 can't be an option. 4 can't be an answer. So 1, 2, 3 will be the answers. So this is our desired set. Now for the next problem, you see that x is a natural number where x is greater than 6 but less than 7. But if you look closely, you'll see that between 6 and 7, between 6 and 7, right, like in a number line, if we draw, so 0, 1, 2, 3, 4, 5, 6, 7. So between 6 and 7, there are no natural numbers. So this is written as an empty set. This is written as an empty set. It can be represented like this or like this. So again, in number 4, x again is a natural number where x will be less than 10 and it will only be even numbers. So if we write down all the even numbers that are less than 10, all the even natural numbers that are less than 10, we get 2. Since 1 is an odd number, we get 4, we get 6, we get 8, and that's just it. So this is the answer for number 4. Okay, here, for problem number 5, x belongs to the natural numbers, where x is a factor of 42. For 42, to find out the factors, we can do a trick. The trick is like, right, 42, and we try to divide it with 2 or 3. Now, with an even number, it's divisible by 2. But how do we know if it's okay, let's first divide it by 2 since it's an even number, so we'll get that 22 is 4 and 21 it's 2, so you get 21. Now, since 21 is an odd number, it is not divisible by 2. But is it divisible by 3? We have to find that out. To figure that out, we have to add the two numbers of 21. It's 2 plus 1 is equal to 3. Now, since 3 is definitely divisible by 3, so 21 is also divisible by 3. So if we write 3, we get 7. Right? How do you know it's like 3 into 1, 3 into 2, 3 into 2 is 6, 3 by 3 is 9, 3 by 4 is 24, 3 by 5 is 15, 3 by 6 is 18, 3 by 7 is 21. You just have to know that, and then you're all good to go. Now, 7 is a prime number, so we can't divide it anything other than 7. So now if we try to figure out the factors, we can write that 1 into 42 is 42, 2 into 21 is 42, 3 into what will be 42, since 4 plus 2 is equal to 6, and 6 is divisible by 3, so 42 is also divisible by 3. Yeah, you're right, we can say that 3 times 1 is 3, and then we have a leftover 1, and here's 2, so 3 times 4 is just 3 times 14 is actually 42. 3 times 14 is equal to 42. Now, we know that 4 times 10 is 40, so 4 times 11 would be 40 plus 4 is 44. So 42 is not divisible by 4. And since the last digit of 42 is not neither 0 nor 5, 42 is definitely not divisible by 5. Now, since previously we found that 4 plus 2 is 6, that is 42 is divisible by 6. We can check that out. 6 into 7 is equal to 40. How do you know that? We just have to know the multiplications. The sequence of multiplications. Now that 6 into 1 is 6, 6 by 2 is 12, 6 by 3 is 18, 6 by 4 24, 6 by 5 30, 6 by 6 36, and 6 by 7 is 36 plus 6 is 42. So that's it. These are all the factors. These are all the factors of 42. So we can write we can write now from this that this set will be 1, 2, 3, 6, 7, 14, 21, and 42. And the next problem, so you're told that x is an actual number where x is less than 19, and x is a multiple of 3. Now, since x is a multiple of 3, we'll write all the multiples of 3, including 3 itself. Since 3 by 1 is 3, so 3 by 2 is 6, 3 by 3 is 9, 3 by 4 is 12, 3 by 5 is 15, 3 by 6 is 18, but 3 by 7 is 21. And since x is less than 19, we have to stop here. So this is the answer. Okay. Now, for this problem, we're told that a and b are the sets of all the factors of 315 and 512 respectively. And now we have to identify, determine a and b. So let's say for 315, a is equal to a set of all the factors of 315. So what are all the factors of 315? First of all, 1 is definitely a factor of 315. Now 315 is an odd number, so 2 is not a factor. If we add the numbers of 315, that is 3 plus 1 plus 5, we get 9. So 3 is a factor of 315. So we get 1, and here we get, what do we get over here? It's 5. It's 0, 5. It's 0, 5. So 315. It is definitely not, 4 is definitely not a factor of 315 since it's an odd number. 5 is a factor since the last number is 5. So you can write 5 into 5 into 63, 315. Now, since if we add up the numbers of 3 to 15, it is 2 plus 1 is over 4 plus 5 is 9. Now, since 9 is not divisible by 6, 315 is not divisible by 6. 6 is not a factor of 315. Is 7 factor of 315? Yes, 7 is a factor of 315. One way of knowing is that if we multiply the last digit, that is 542, and get the number which is 10 here, and then we subtract that number from the rest of the numbers, that is, we subtract 10 from 31. We subtract 10 from 31. And the number that we get, if this is divisible by 7, which it is, you can say, then 315 is divisible by 7. So here we get, okay, so 7 to 45 is 315. 315 is not divisible by 8, but 315 is divisible by 9. Okay. So it comes in central. So 9 into 35 is 315. It's not divisible by 10, not by 11, definitely not by 12. Is it divisible by 13? No. One way to figure that out is that we'll take the last digit of 315, right? We'll take the last digit and we'll multiply that with 4. We'll multiply that 4, and then we will add this product with the rest of the numbers. We get 6. If this is divisible by 13, then the entire number would be divisible by 13. Since 41 is not divisible by 13, 315 is not divisible by 13. Now, 315 is not divisible by 14. You'll see that 7 into 45 is 314. For 314 to be divisible by 14, we needed an even number, or a number here, which would have been divisible by 14 itself. Okay. Now, 315 is divisible by 15. It is divisible by 15, since 315 is divisible by both 3 and 15. And if we use a calculator, we'll see that 1521 is 350. By the way, for theory exams, you are allowed to use a calculator on screen, which will be provided by the exam authority. Now, 315 is not divisible by 16, is not divisible by 17, is not divisible by 18, is not divisible by 18, it is not divisible by 19, either not by 20, since it's an odd number, so again, it is divisible by 20. So these are all the factors of 315. So from here, we can write the sets of 315, that is A is equal to 1, 3, 5, 7, 9, 15, 21, 35, 45, 63, 105, 050. So we can calculate all the factors of 512 and write down the set B. Now, I'll leave that to you to figure it out. If you can't figure it out, leave it in the comments and we'll say later. There are some things that I want to show you. Why 315 is not divisible by 16. Now, 315 to be divisible by 16 was it needed to be divisible by, it had to be even number than the later conditions would have been applied. The reason why 315 is not divisible by 17. Now, for a number to be divisible by 17, we'll take the last digit and then we'll multiply it by 5. Then we'll subtract the rest of the numbers. We'll subtract the product from the rest of the numbers. And the number that we get, in this case here, it's 6. If that is divisible by 17, then the entire number would be divisible by 17. Since it is not, 6 is not divisible by 17, 315 is not divisible by 17. So that was it. So I think we can figure out set B a similar way. So now we're going to solve this problem over here, where we're asked to determine a set of natural numbers which when divides 311 and 419, every time there's a remainder of 23. Now, this is similar to the examples that we did earlier. So at first, we're going to subtract 23 from 301. So if we subtract 23 from 301, we'll get and it's 288. And if we subtract 23 from 419, we'll get 396. So now we're going to figure out the sets of the set containing the factors of 288 and 396. Now for 288, the factors would be like definitely 1 is a factor, right? So is 288 divided by 2? Definitely 288 when divided by 2 would be 144. Now if added the numbers to 2, 8 and 8, we'll get 8 plus 8 is 16 plus 2 is 18, which is divisible by 3. So 288 is again divisible by 3, and we'll have 96. Right, so we'll have 96. Definitely you can see that 288 would be divisible by 4. Also, if we see that the last two digits are 288, uh, if we take these digits, we take the last two digits of 288, which is 88, and say that if they are divisible by 4, then 288 is divisible by 4. And now you can see that 288 is divisible, 88 is divisible by 4, 288, so 288 is divisible by 4. So you can write that 4 into 7 by 8 is 8. Yeah, that should be it. Now, since 208 log 0 of 288 is not 0 or 5, so 288 is not divisible by 5. However, since adding the numbers 2, 8 and 8, we get 18. 288 is divisible by 6, so we'll get 48. And now, is 288 divisible by 7? So using the earlier trick that we done, or using the calculator, since 288 is not divisible by 7, is 288 is divisible by 8. Now, in terms of 8, we'll have to take all the three numbers, and this is the entire number comes up. So, if we use the calculator, yes, 288 is divisible by 8. Since the summation of 2, 8 and 8 is 18, 288 is divisible by 9, we would end up with 32. 288 is not divisible by 10, and as it stands, 288 might not be divisible by 11. Now, other than calculator, there is another way of figuring out if a number is divisible by 11. What we can do is we'll take the sum of the oddly placed digits. In this case, it's 2 and 8. Let's take their sum, 2 plus 8, and we'll subtract that from the evenly placed digit. In this case, it's 8. This can be done vice versa. That is, we can also do 8 minus 2 plus 8. So here we will get 10 minus 8, which will go to 2, which is not divisible by 11. So the number 288 is not divisible by 11. Now, is 288 divisible by 12? As you can see that 288 is divisible by 3 and 4, 288 is divisible by 12. And in this case, we'll get 24. Is 28 divisible by 13. Using the earlier trick of the calculator, we can see that 288 is not divisible by 13. Now, since 288 is not divisible by 7, but 288 is not divisible by 14. 288 is not divisible by 16. 288 is, however, divisible by 16, and it is divisible by both 8 and 2. Now, these are all the factors. These are all the factors of 288. Now, for the other number, which was 396. 396. We'll have 1 into 396, 2, 2 into 198, and adding the numbers, we'll get 18 again, it's 18, so dividing it by 2, we get 100, and 32. Now the last two digits, which is 96, is divisible by 4. So 296 is divisible by 4. And we get 99. We get 99. It's not divisible by 5, however, it is divisible by 6. And we get 66. It does not look like, most likely, it's not divisible by 7. Now, I think is divisible by 8. Nope, it's not divisible by 8. It is divisible by 9. So we get it's not divisible by 10. It's not divisible by 11. Oh no, wait, it is divisible by 11. It's divisible by 11 because if we add number 6 plus 3 is 9, minus 9 is 0, and 0 is divisible by 11 as we get here. So it is divisible by 11. If it is divisible by both 3 and 4, it's divisible by 12, and we get 33. Don't think it's divisible by 13, no, it's divisible by 14, no, 15, no, 16, also no, 17, no, 18, yes. Let's see that the gap is closing up. See the gap over here, 1 to 296, 2 to 198, 3 to 132, and that closed up to 12 to 33, and now 18 to 22. It could end up in the same numbers multiplied, or it could just be a gap of 1 or 2 numbers. Let's say it's now. It is not divisible by 19, not by 20, and definitely not by 21. So this was the last. So now let's figure out the commons. And those numbers when used to divide all the numbers which leave remainders of 23. Remainders of 23. And we go to the common, we got 1, 1, 2, 2, 3, 4, 3, 4, 6, we got 9, we got 12, 12. There's no 16, we got 18, 18, 22, 22, 33, 33, we got 36, 36, 44, no, 66, no. I think that's all. That's about it. So we take these numbers, we'll get our answers, which is after over here. Right, so we can test it out. Assurance. We'll divide the 18. We'll divide 311 divided by 18. Or we'll divide 288 divided by 18. Yep. 311 will divide by 18. So 8 to 8, 1 to 1, we get 30. It's 30. Here is another 1. So how many times would that be? It would be 7 times. So 7 will get 126. Negative 5. Okay, there was a slight mistake. Earlier I said that we have to take all the common factors that would make up our set, but there was a mistake. We have to take the common factors that are greater than 23. That are greater than 23. Only then we get the set of the desired numbers. That when you divide 211 and 419, we leave a remainder of 23 everything. And for example, here, when 211 is divided by 18, we get 17, but the remainder would be 5, right? Because 18 is less than 23. When we use 36, which is greater than 23, we'll have the remainder as 23. So when choosing numbers for our set, we'll have to take only those numbers that are greater than 23. So in this case, we can take 36 from here, and yeah, so it's like 36 is the only answer. So similarly, you can do this one. So what you'll have to do is that you have to do for this one is first you have to subtract 35 from both this number. So uh, we'll get 70, and from here uh, we'll get 112. Now we have to find the factors of these numbers and the common factors. We take only those common factors that are greater than 35. Otherwise, it won't match your answers. Okay, moving on into the next problem, we have A set and B another set. And what would be A union B and A intersection B? Now, A union B would be the common elements of both the sets. In this case, we have only 3. So A union B would be 3. And for, sorry. A union B uh, would be uh, a set that will comprise of all the elements of both the sets. So in this case, we'll have 1, 2, 3, A and B. Notice that even though 3 exists in both the sets, we have written it only once since it's a common number. So that's how we'll transform uh, A and B from A to A and B. For A intersection B, we'll take only the common value, and in this case, it's 3. So in this case, it will be just 3. Now here they're given a set, and then they're asked to write uh, three real subset. 3 real subsets will have 3 elements each. We have 3 elements each, so we can arrange this. We can write it like this. So if we write it, one of the subsets will be -1, 0, 1. Another subset will be 0, 1, 2. And another subset will be 2, -1, 0. So notice how we went. We took this 3, and then we took this 3, and then we went around about, and we took like this one, and then this 2. That's how we uh, that's how we built our 3 sets comprising of 3 elements, and these are real subsets. Now, if you remember the definition of real subset, it was so if say A is a set and all of its elements are present in another set called B, and uh, there's at least one element in B which is also present in set A, then we can write, or we can say that A is a real subset of B. Right? A is a real subset of B. Now we're saying that these are real subsets of B because all of these elements are present in B, and at least one element of B, in this case it's more than one, its 3 elements are present in these subsets that we have formed. In the next question, they're given 2 sets, right? They're given 2 sets x, y, and they were asked to find the intersection of x and y. Now, when we have to find the intersection, we have to find the common, and in this case, there are no common between the elements of these 2 sets. We'll write x intersection y either like this or this, which means it's an empty set. It's an empty set. So again, A there is a set and B is an empty set. So what would be A union B, A intersection B? So A union B would be A. It's quite easy to assume A union would be whatever A is given. And for B intersections, A intersection B, since there's nothing in common, that will be this, which is actually B. Okay, now we have to solve problem number 9. So in the first problem, we have to figure which is A minus B. Here, A minus B is basically this, which means the complement of B with regards to A. That is, this will this will contain those elements of A which are not included in set B. So if we see here that here A minus B or complement of B with regards to A would be so this would be 1, 3, 5, since A and B has no common elements. Okay, if A and B had a common element, we will test that out. C minus B would be the complement of B with regard to C, that is, those elements of C that are not present in set B. You see that 2 and 4 are both present in B and C, so C minus B would be 3, 5. Complement of A would be those elements of A that those elements of the universal set, those elements of the universal set which are not present in set A. So since set A comprises of the odd numbers 1, 3, 5, so the complementary A would be 2, 4, 5, 6. In the same way, complementary B would be 1, 3, 5. A complement of A, union complement of C. We know the complement of A, so it's complement of C. Complement of C is if you left 2, 3, and 5, since the universal contains 8 to 1 to 6, and you have 1 and 6. So the intersection between the union between these two sets would be 1, 2, 4, 6. Okay. Since 6 is common, we use only for ones. The complement of A, the complement of A is this one, and the complement of B is this one. So their intersection, there is no intersection, they don't have any in common, so it will be an empty set. Okay. Number 10 here, what are we asked? We're asked to find if the following equations are true. Following equations are true to verify these relations that are given. So here, so here in the first problem, what have they asked? They have asked, so the first one we have to show, we have to verify that if A union B complement is equal to A complement intersection B complement. So what is A union B? We can see that the A union B would result in U, since A contains the odd numbers of U and B contains the even numbers of U. So if we unify these two sets, we'll get the entire U set. So the complementary set of the entire U set, or A and B, would be an empty set. And the intersection of complementary set of A and B complement is also an empty set. It is an empty set as we have found over here. So we can say that this is true. This is true. For the second problem, you can see that B intersection C we'll see that for B intersection C, we have 2 and we have 4, right? So we have 2 and 4. And for complements of B, so this, what is complement of B? Complement of B is actually set A, which is 1, 3, 5. Now, sorry, I made a mistake. Okay. B union C is 2, 4. The complements of this with regards to the universal set, with regards to this universal set is 1, 3, 5, 6 now. Complement of B is this. Complement of C is 1, 6. When we unify this, we'll get 1, 3, 5. So you see, the common numbers is written only once. It's not repeated. So you can see that these two are equal. So this is also verified. For the problem number 3, we have to figure out A and B intersection C. Yeah, that's right. Okay, now A union B. So A union B would result in U. Okay, this would result in the universal set. The intersection with the universal set will only have the members of C, because universal set contains all the elements of A, B, and C. So the intersection, so this entire thing would contain C sets, basically the C set. Now A intersection C, right? So A intersection C. Listen over here. A intersection C. We can see that in A intersection C, what we have 3, we have 5. 3, and there are 5. So that's 3, and there's 5. And B intersection C, which we have it down over here, right? B intersection C. B intersection C, we have 2, 4. We have 2, 4. And we have to unify these two sets. We'll unify it, and what we'll get is 2, 3, 4, 5, which is basically, if you notice, is set C, right? So this is basically set C. So we can write here that this is also C is equal to C. This is true also. For the next problem, we're going to clear this up, so mess of it. Okay, by the way, these pages are taken from the from the book of class 9 and 10 of the national curriculum from Bangladesh. It's the secondary algebra. It's the secondary algebra book. The page number is actually 5 and 6 for your reference. That is, I'll try to write it down at the end of the class for your ears. You might not find these books in the market right now. These are used. Few years back. This is actually republished in November 2010. Later on, there were new books, new publications, so these are, I believe, obsolete from the market. You won't find them in the market. So, yeah, we have to now solve number 4. Now, A intersection B, if we see that A and B, there is no common, so it's an empty set, and C. When you try union this, it will turn out to be C. Now, A union C on the other hand, there are 3 and 5, which is previously. between A and C. A union C is 3 in common, 3, 5, 5 in common. So this union, I'm going to write down this as 1, 2, 3, 4, 5. And B union C would be this would be this would be 2, 3, 4, 5, 6, right? So 2, 3, 4, 5, 6. Now the intersection between this the intersection between this sorry, yeah, the intersection if it's only the common which is this and this. So it's basically uh this which is again set so right. So yep, this is also true. Okay. Now for the last one of this sort of problems we have A union B. And again, A union B is actually U, right? As equal to that is on the right hand side complement of B with regards to respect to A. This means again the elements of A present in uh, the elements of A that are present sorry, this would mean those elements that are not present in A but present in B. So it just basically would mean set B, and this would mean set A, and this action empty set. So when you merge again this, instead of to merge it, when you merge it's actually U. When you merge U with an empty set, right? It's U empty set, you're gonna get U. So basically what we're getting is U is equal to U. So this is also true. Okay, this is also true. Alright, now to the next problem. Here in number 11, we have, okay, they have given us two sets like A, B, C, and they've asked us to show that A union B union C is equal to A union B union C, and A intersection B intersection C is equal to A intersection of B intersection C. Okay. This one's actually very similar. If you write A union B, okay, you can see that between A and B there's two common. Between C and A there's one is common. Between B and C we have four common. So that's out of the way. Okay, now if you write we get is that A union B. So is A union B. A union B would turn out so we get 1 since 2 is common. We'll take 1, 2, and then it's 3, and that's 4, and that's 6. This is A union B, and when that's merged with C, you see we have 1, we have 2, we have 3, we have 4, we have 6, and we have 7. So now 5. We have 1 to 7 without any 5. I'm taking B union C, right? So we're taking B union C. We'll get is is 2. Sorry, we get 1 first since there's 1. So we get 1. There's 2. There's no 3. There's 4. There's 6. There's 7. There's 7. I'm merging this with A. Merging this with A. We'll get A 1. So basically, the leftover, which was in this it was 3, is now taken from A, and this is the result again. Another set consists of the numbers 1 to 7, but no 5. So we can see that these two sets are equal. They have the same elements, so they're equal. So this is true. This is true. Similar way, if you try this one, you'll see that this is also true. Okay, so I'll let this go for you to try it out at home. Now, the last two questions, which is a bit big questions, and so this below, yes. Here we are asked, uh, in a class, there were 100 students, right? In a class, there were 100 students. In the final exam, 94 of them passed in Bangla, okay, language for people. 80 passed in math, okay? 80 of them passed in math. 75 of these students passed in both Bangla and math, both subjects. Now we have to present this through a Venn diagram. Also, we have to figure out how many students failed in both the subjects, right? Okay, now the total number, right? The total number of students who represent this with this rectangle, which is also which also represents a universal set. The universal set is the total number of elements, right? So this is 100. Now, you find the exam numbers in passed in Bangla. Say this is the number of students passed in Bangla. This is 94, and the number of students passed in say what say math is represented by this circle, and this is actually 80. Yeah, math is 80. Okay. Now that we're told that 75 has both the subjects, so these students are 75. So we're gonna write this both the subjects. So what is it? Two T for two. Both the subject 75, right? So now from this diagram, we're to figure out how many students failed in both the subjects. This would include these students, like these students that are within the box but outside the circles. They were present in the class, but they didn't pass in any of the subjects. How do you figure this out? First, we have to subtract. We'll have to subtract the number of students who passed in Bangla. We have to subtract the number of students who passed in both the subjects from the number of students who passed in Bangla. By doing so, we get the number of students who passed in only Bangla. So here, we do that by 94, the number of students passed in Bangla, and we we leave out 75 students. 75 students who passed in both subjects. Thus, we get is equal to, what do we get? We get 19 students. So 19 students passed in only Bangla. Now here, there's 80 students passed in math, but there were 75 students. Okay, so how many students passed in only math? The number of students who passed in math was 5. So the total number of students who passed in either one subject would be E minus T union T union M N minus T. This is 19 plus 75 plus 5, which is added to and what, so 80 999. So this is 99. So we will have the answer is, if we subtract this number from the total number, which is 100, we'll have 100 minus 99 is, so only one student seemed to have failed in both the subjects. Okay. Alright, only one student seemed to have failed in both the subjects. Now, for the next one, and the last one for this chapter. Here we're told that class of 25 students, each student were given an option to choose at least one of the subjects from computer science or higher mathematics. So from a class of 25 students, they're given the option to choose at least one of two subjects, computer science and higher mathematics. And it was seen that 12 students took computer science. Among the students, uh, 8 students didn't take higher mathematics. Now we were asked to figure out the number of students who took both the subjects and the number of students who took only higher mathematics. Now, as a total number is given as 25, so we can draw a Venn diagram to make it simplify this matter. So first, this is the rectangle. This is a rectangle, so here this is 25. Okay. Now, 12 students to computer science. So say 12 students these are to computer science. Yes, computer science. Now, among these 8 students didn't took higher mathematics, so they took only computer science. So only computer science. So let's say these students took higher mathematics and these students took both subjects. These students took higher mathematics, took both the subjects. So we can write here is that this is both. This time we're gonna identify or write this as B, which is both. So both. What does this mean? This means that the number of students who took only computer science, only computer science is 8. Is 8. Right? This is 8. And okay. Now from this equation, we can easily write this equation, right? This equation, what can we write? Is that 12 minus B is equal to 8. So B, that is the number of students to both the subjects. Equal to 12 minus 8, right? You take this over here, this becomes minus 8 is here, so this becomes plus C. So this would be what? This would be 4. This would be 4. So 4 students took both the subjects. So that was first question. How many students took both the subjects? 4 students took both the subjects. The second question, how many students took only higher mathematics? Now we can see the total amount of students is 25, and according to the question, each student has to choose either one or both the subjects. Now this means that the total number of students, which is 25, will equal to students who took only computer science, which is 8, students who took both computer science and mathematics, which is 4, and students who took only higher mathematics, right? Only higher mathematics. And if we were to show this in the Venn diagram, this would be these students, these are the students. They took only higher mathematics. Okay, so now we can calculate this number. This would equal to, this is 12, right? This is 12. And when 12 goes over here, it's a minus 12, so 25 minus 12. So 10 goes out to 15 and more 13, it is 13. So 13 students took only higher mathematics. This was the question. Answer to this question. So that's it for chapter 1. I hope you liked it, and if there was any problem with this video, is there any problem with this lessons, any topics you understand, any uh, subjects that you need to know that will help you understand this better, uh, please write it down in the comments so I can get back to you at my earliest convenience. And uh, to let you all know that these are very rough videos that I'm making for myself to prepare for GRE, and also to help those who may not be from a proper science background, may have forgotten the math they did in at school level, especially if you're from Bangladesh, from the national curriculum, then maybe this would help you out a bit as well. So that's it for today. Thank you and good luck.